In this module, you will learn about the trigonometric functions of sum and difference of two angles. Recall that sine of A plus B is equal to sine A into cos B plus cos A into sine B. Sine of A minus B is equal to sine A into cos B minus cos A into sine B. Cos of A plus B is equal to cos A into cos B minus sine A into sine B. Cos of A minus B is equal to cos A into cos B plus sine A into sine B. Tan of A plus B is equal to tan A plus tan B divided by 1 minus tan A into tan B. Tan of A minus B is equal to tan A minus tan B divided by 1 plus tan A into tan B. Let us derive some more formulae. First, let us prove that cos 2A is equal to cos square A minus sine square A, which is equal to 2 cos square A minus 1, which is equal to 1 minus 2 sine square A, which again is equal to 1 minus tan square A upon 1 plus tan square A. We know that cos of A plus B is equal to cos A cos B minus sine A sine B. Replacing B by A in the formula, we get cos 2A is equal to cos square A minus sine square A. We know that sine square A plus cos square A is equal to 1, or sine square A is equal to 1 minus cos square A, or cos square A is equal to 1 minus sine square A. It implies that cos 2A, which is equal to cos square A minus sine square A, can be written as cos square A minus of 1 minus cos square A, or 2 cos square A minus 1. Now, substituting cos square A is equal to 1 minus sine square A, we get 1 minus 2 sine square A. Now, let us again consider cos 2A is equal to cos square A minus sine square A. Multiplying and dividing the right-hand side by cos square A, and then rearranging the terms, we get this. Now, this can be written as 1 minus tan square A divided by secant square A. Recollect that secant square A is equal to 1 plus tan square A. This implies cos 2A is equal to 1 minus tan square A by 1 plus tan square A. Let us now prove the result sin 2A is equal to 2 sin A into cos A, which is equal to 2 tan A divided by 1 plus tan square A. Recall that sine of A plus B is equal to sine A into cos B plus cos A into sine B. Replacing B by A, we get sin 2A is equal to 2 sin A into cos A. Now multiplying and dividing by cos A, we get 2 sin A by cos A into cos square A, which is equal to 2 tan A divided by secant square A. It implies that sin 2A is equal to 2 tan A divided by 1 plus tan square A. Now, let us find the formula for tan 2a. Recall that tan of a plus b is equal to tan a plus tan b divided by 1 minus tan a into tan b. Replacing b by a in the formula, we get tan 2a is equal to 2 tan a divided by 1 minus tan square a. Now, let us learn some formulae that involve an angle 3a. The first is sin 3a is equal to 3 sin a minus 4 sin cube a. Consider the left-hand side. Sin 3a can be written as sine of 2a plus a. Recall that sine of a plus b is equal to sin a into cos b plus cos a into sin b. So, sine of 2a plus a can be written as sin 2a into cos a plus cos 2a into sin a. Now, sin 2a is equal to 2 sin a cos a, and cos 2a is equal to 1 minus 2 sin square a. On substituting, we get 2 sin a into cos square a plus 1 minus 2 sin square a into sin a. Substituting cos square a is equal to 1 minus sin square a. We get 2 sin a minus 2 sin cube a plus sin a minus 2 sin cube a. On simplifying, we get sin 3a is equal to 3 sin a minus 4 sin cube a. Let us now prove that cos 3a is equal to 4 cos cube a minus 3 cos a. Cos 3a can be written as cos of 2a plus a. Recall that cos of a plus b is equal to cos a into cos b minus sin a into sin b. Using this, cos of 2a plus a can be written as cos 2a into cos a minus sin 2a into sin a. We know that cos 2a is equal to 2 cos square a minus 1, and sin 2a is equal to 2 sin a into cos a. On substituting the values and simplifying, we get cos 3a is equal to 4 cos cube a minus 3 cos a. Now, let us prove tan 3a is equal to 3 tan a minus tan cube a divided by 1 minus 3 tan square a. Tan 3a can be written as tan of 2a plus a. Recall that tan of a plus b is equal to tan a plus tan b divided by 1 minus tan a into tan b. Using this, tan of 2a plus a can be written as tan 2a plus tan a divided by 1 minus tan 2a into tan a. Substituting tan 2a is equal to 2 tan a divided by 1 minus tan square a, we get this. On simplifying, we get tan 3a is equal to 3 tan a minus tan cube a divided by 1 minus 3 tan square a. Let us now prove some more results. The first one is sine of a plus b plus sine of a minus b is equal to 2 sin A into cos B. Consider the left-hand side. Sine of A plus B is equal to sin A into cos B plus cos A into sin B, and sine of A minus B is equal to sin A into cos B minus cos A into sin B. On simplifying, we get 2 sin A cos B. Hence the result. The second is sine of A plus B minus sine of A minus B is equal to 2 cos A into sin B. Consider the left-hand side. Again, sine of A plus B is equal to sin A into cos B plus cos A into sin B. And sine of A minus B is equal to sin A into cos B minus cos A into sin B. On simplifying, we get 2 cos A sin B. Hence the result. The third is cos of A plus B plus cos of A minus B is equal to 2 cos A into cos B. Consider the left-hand side. Cos of A plus B is equal to cos A into cos B minus sin A into sin B. And cos of A minus B is equal to cos A into cos B plus sin A into sin B. On simplifying, we get 2 cos A cos B. Hence the result. The fourth one is cos of A plus B minus cos of A minus B is equal to minus 2 sin A into sin B. Consider the left-hand side. Again, cos of A plus B is equal to cos A into cos B minus sin A into sin B. And cos of A minus B is equal to cos A into cos B plus sin A into sin B. On simplifying, we get minus 2 sin A into sin B. Hence the result. Let us now prove few more formulae. Let us assume that A plus B is equal to C and A minus B is equal to D. On solving for A and B, we get A is equal to C plus D by 2 and B is equal to C minus D by 2. Now, substituting these values in the identities, we get Next, let us prove sin of A plus B into sin of A minus B is equal to sin square A minus sin square B, which is equal to cos square B minus cos square A. Consider sin of A plus B into sin of A minus B. Substituting sin of A plus B is equal to sin A into cos B plus cos A into sin B. And sin of A minus B is equal to sin A into cos B minus cos A into sin B. On simplifying, we get sin square A into cos square B minus cos square A into sin square B. This is further equal to sin square A into 1 minus sin square B minus 1 minus sin square A into sin square B. On simplifying, we get sin square A minus sin square B. Now, sin square A minus sin square B is equal to 1 minus cos square A minus of 1 minus cos square B. This is equal to cos square B minus cos square A. Now, let us prove cos of A plus B into cos of A minus B is equal to cos square A minus sin square B, which is equal to cos square B minus sin square A. Consider cos of A plus B into cos of A minus B. Cos of A plus B is equal to cos A into cos B minus sin A into sin B, and cos of A minus B is equal to cos A into cos B plus sin A into sin B. On simplifying, we get cos square A into cos square B minus sin square A into sin square B. This is further equal to cos square A into 1 minus sin square B minus 1 minus cos square A into sin square B. On simplifying, we get cos square A minus sin square B. Now, cos square A minus sin square B is equal to 1 minus sin square A minus of 1 minus cos square B. This is equal to cos square B minus sin square A. Now let us prove the last result. Using the formula tan of A plus B is equal to tan A plus tan B divided by 1 minus tan A into tan B. Tan pi by 4 plus A is equal to tan pi by 4 plus tan A divided by 1 minus tan pi by 4 into tan A. This is equal to 1 plus tan A divided by 1 minus tan A, as tan pi by 4 is equal to 1. Now, substituting tan A is equal to sin A by cos A, we get cos A plus sin A divided by cos A minus sin A.